check for understanding, your understanding for the balanced and unbalanced force. So I just want you to take a few minutes to read the question. So it says, Luke drops an approximately 5 kilogram box of shingles, so they weigh 50 Newton, off the roof of his house into the swimming pool below. So upon encountering the pool, the box encounters a 50 Newton upward resistance force. So what does that mean? So when we say we have 50 Newton down and 50 Newton up, you gotta think about it. Use this description to answer the following questions. Which of the velocity time graph best describes the motion of the box? So what does it say? It says that the box was dropped, right? Here, let's underline the keyword. So there was first a drop, right? And then after the drop, there was 50 Newton, which is the same as this, that is assumed to be constant. So first it was dropped, and then it's moved at a constant speed. So which graph shows it? Let's analyze each graph by itself. So if we talk about graph A, we notice that in graph A we have the speed started to decrease. So there was deceleration in the speed, and then the speed started to accelerate again. If we look at graph B, it started decreasing, or we say it dropped and then it went up. Same thing for that one. It dropped and then it moved at a constant speed. While as for C, it actually started off constant and then it was thrown up or it was accelerated. So if we want to think about what we have given in the question, it seems like graph B is the one that satisfies that statement. Okay, so let's write it, and we're going to write the reasons why. So we're going to say the box, so it's B. So the box first accelerates with a negative downward acceleration. Until it hits the water. So how do I know that it's accelerating in a negative downward? Because the speed is in the negative zone, and here that one says it drops. So I know it's going downwards. All right, upon hitting the water, so what happened when it hit the water? The box experiences a balance of force (50 Newton) downward and why is that? It's due to gravity. And 50 Newton, which is the normal force, upwards. So which will lead into a constant velocity. And that is the only one that dropped and then continued at a constant velocity. All right, let's check number 2. Which of the following dot diagrams best describes the motion of the falling box from the time that they are dropped to the time that they hit the bottom of the pool? So we're just looking at the motion where it was dropped and then it hit the water or the bottom of the pool. All right, so as you see, this goes so as you look at this one is really accelerating until it hits the water. So there is a change in velocity because you can see how the dots, they started really close to each other and then they spread out. And then it hits the bottom. For B, it's going kind of at a constant speed. For C, it is changing in velocity. So there is acceleration, but it did not hit the bottom of the pool. So which means A is your right answer. So the box first accelerates with negative acceleration until it hits the water. All right, and then there was change in acceleration, and then it moved into constant speed, and it hit the bottom of the pool. So this is the first example, and I'm going to post another video for the second.